Good morning, everyone. I'm Kavitha, Assistant Professor, Department of Civil Engineering, VSB Engineering College. Today, we will discuss some introduction part of design of flexural members. So, these are all the main content in the design of flexural members. There's different types of beams and section classifications, laterally stability of beams and stresses like shear, bending, and bearing stresses, and effective length of compression members, and laterally supported and unsupported beams, and the build-up beams. So these are all the main content. So this is the main course objective of this unit, and these are all the text and reference books as are followed. And first of all, we should know what are all the different types of BBs. We all know. So we have some kinds of we have some different types of beams are available, right? So it is a simply supported, cantilever, overhanging, continuous, and fixed. If the both ends are fixed, mean it is called as a fixed end beams. Both ends are simply supported is a finite connection is simply supported beams, and one end is fixed, another one end is free. It is a cantilever beams, and more than two subjects are provided, that is called continuous beams. So likewise, we will also have some sectional classifications also, though this will you first one is a universal steel sections. Like what are all the universal steel section? That is T sections, I sections, and channel sections. So this is a cold form thin walled sections. This may be a channel like a channel sections, right? And also welded and woven web sections. So these are all the main sectional classifications of the steel sections. So first of all, we should the introduction part about the flexural members. So what does mean by the flexural members? Mostly these elements are mainly subject to the bending moments. So some example of this bending moment is a beams and girders and rafters. So in steel structures, this flexural member carry the transverse load, and also it will resist the deflection also. Bending, it will be resisting deflection, bending, and shear, and sometimes it will resist the torsional force also. So it may be affected by some category. So this behavior of the flexural member can be affected by some of the categories, like section properties. What are all the section properties? Like area after the moment of inertia, after the section modulus, the Z is equal to section modulus, right? So these are all the content. These are all the affected factors of the behavior. Next one is material grade, like yield strength, material grade. Finally, the support condition. We all know that both supports are fixed, are simply supported, cantilever. So likewise, and the restraint conditions also. So these are all the affected criteria of the behavior of the flexural members. So these are all the main types of flexural member. First of all, it is rolled steel sections. We all know I-beams, channels, and angle section likewise. So what is the build-up section? The plate girders and welded beams, or it is called as a build-up section. What is encased beams? If the rolled steel beams are encased with a concrete member, we have one image will show this encased beam classifications, right? We will explain. Next is composite. What does mean by composite? The combination of two members, the steel and the concrete, the combination of two members, and laterally restrained, unrestrained. So the laterally restrained, unrestrained, there is no, there is restrained means it will reduction in the buckling. There is unrestrained, there is no reduction, there is it is free movement of the forces, right? So it will be compression flange to the tension and the compression. So this will be varying for the restrained condition, another one unrestrained condition. We will see in this later, right? Next is stress distribution. Here this the bending force will produce the compression on one side, and it will produce tension on the other side. So that will be the stress distribution in this flexural member. We have to consider both tension and compression. So which member will carry the tension and which member will carry the compression, we have to understand. Likewise, here what is mean by central? This central point of the section. So the neutral axis mainly pass through the centroid here. So how will calculate the stress? That will be calculating by using m into y divided by I. So here it is a linear variation across the depth. So this will be a major consideration, and the design use the plastic section or elastic section modulus, that is called ZP. So this will be the stress distribution, and we have some design procedure here. Initially we just what mean by what will be for the design procedure. For if it is taken as a laterally restrained beam, what will be the procedure? What is the design of the bending strength of the section. So here we can calculate by multiplying three values. First one is the section classification factor, next was in section modulus, finally the yield strength of the steel with the partial safety factor. So these are all the criteria here. So first one is basics classification section classification factor. So this will be very easy because this section is a plastic section or compact section or semi compact section. Based on the condition, we can take it as a value. Next one is Z section modulus. We have to calculate the section modulus for ZP and ZC for the compact section and the semi compact section. We have to calculate this value. Finally, Fy value we already know from, we can take it as from code book, yield strength of the steel, and the partial safety factor usually we can take it as a 1.1. So from that we can easily calculate the design strength of the beam. That means the bending strength of the section. So what does mean by laterally restrained beam and laterally unrestrained? So the compression flange is restrained against lateral buckling, that is called lateral. Then it will not reduction the bending strength, and it will use for full plastic sections. It is or the elastic moment capacity, because there is it is restrained, so it will be using for the plastic section. It and also it ensure the local buckling and shear. It's do not the it will not cover under the design criteria. So laterally unrestrained means the main basic condition is here, it will be considered, it will be covered the lateral torsional buckling. We have to adopt this criteria here. And also the effective length increased if the unbraced length is increased. If due to this means the effective length will be varied here. So in this also a reduction in bending capacity can be calculated by using the same method, but here one is the factor is varying. What is the factor varying here is the lateral torsional buckling ratio factor, reduction factor will be varied. We can be take it from the IS 800. So next will be the elastic section modulus of the cross section. Then finally the yield strength of the material, right? Finally the partial safety factor, we can take it as here also it is 1.10, right? So next will be the factors influencing lateral torsional buckling. So these are the main factor influencing the lateral torsional, because it is unrestrained conditions. The length between the restraint, that will be a major role, major playing role here. And the load position, how it will be load is acting in the top and bottom flanges, and the section shapes, that will be a I section or T section, the wrapping rigidity and the torsional restraint at the support. So this will be the main factors influencing this the torsional buckling. So here the calculation of lambda LD, that can be calculated by the non-dimensional slenderness ratio for the lateral torsional buckling. So how it can be calculated? The same calculation will be followed here. The classification factor, the plastic section modulus. It can be a semi-plastic or plastic, whatever it may be. So the here it will be a plastic section modulus and the yield strength. Finally the elastic critical moment, it's mainly depends upon the effective length and the boundary condition and the torsional stiffness. So this will be varying with the criteria, that will be MCR values, right? Then there's a shear strength checks. What is the shear strength checks here? So shear strength checks. So these are all the parameters here. That is V is equal to VD is equal to AV divided by Fy divided by root 3 into gamma m naught. Here AV is equal to shear area, generally the web area. Why we are hearing is a web area? We are providing web area is